Bless you. Okay, hope everybody's having a good day. A few things. Don't forget if you want to retake the quiz from last week, you have until Friday morning, 8:05, to go ahead and do so. If you want to retake a Happy Minutes, it's always within a week of having given it. It's just yesterday, Monday, and today's will be next Tuesday because Monday we're off. We have a 3-day weekend. Um, I won't be here tomorrow, so I'm not going to see you folks. I'll have something left for you to work on. The substitute will pass that out. I just haven't decided what it's going to be yet. I am going to be here in the afternoon. The only other thing I want to bring up is a week from Thursday, the 24th. What's happening? Okay, that's the first exam of the 6 weeks. Okay, so it's going to be happening pretty quick next week. Look for it to have these identities from the current lesson, the sum and difference identities, sine, cosine, tangent, as well as the previous lessons, simplifying those expressions, the verifying, all that good stuff. Okay, so that are the concepts you really want to take a look at. All right, are there any questions before we get started? Okay, well, here are the identities we've been working with, and today we're going to go ahead and finish up as much of the notes as we can. We are pretty much going to finish up, except for I think 1 or 2 problems, and I think the last one, bless you, that we did was number 3, so we are currently on number 4. Okay, so this is connecting it back to the previous lesson where we're proving these statements. We're going to verify an identity. And who else needed... Thank you, Jacob. And then who else needed it as well? Okay, put your hand to Jane when you're done, sir. Okay. All right, so the idea was I need to choose one side of the equation, left or right, and using all the identities, what I know, the algebra skills, somehow rewrite it to make it look like the other side. In this case, number 4, I would probably go with the left side, not only because it's a fraction, but also because you'll notice the numerator is the difference identity for cosine. Okay, so that's the first thing I'm going to do. I'm going to actually expand the numerator in the fraction. Now, what were some of the patterns here? Did cosine alternate or not alternate in the products? Cosine did not alternate, but it did do something. It wanted to change that sign, the operation. Okay, so cosine, if this will give me a little more room here, cosine of alpha minus beta would be cosine alpha times cosine beta. This minus now becomes a plus. Then it's going to be sine of alpha, sine of beta. That's the expansion, and this is all over cosine of alpha, cosine of beta. Okay. All right. So everybody okay with what I've done so far? Just applied the difference identity for cosine. Okay. Now remember, we need to get to 1 plus tangent alpha tangent beta. So how, with the fraction I have, can I do that? So Tish, what do you think? Uh-huh. There you go. So what he's talking about is if you're going to add or subtract fractions, you need a what? Common denominator. Well, the rule is reversible. I can break these apart and have each one with a cosine alpha, cosine beta. So the first numerator, cosine alpha, cosine beta. I'm going to put it over the denominator, cosine alpha, cosine beta. And then I'm going to put the plus second numerator, sine of alpha, sine of beta, over cosine of alpha, cosine of beta. And what are you going to notice with the first fraction? Yeah, they're going to cancel, so that's the 1. Anything divided by itself is 1, which is part of what I already need. Then we got the plus, and we saw last week that we can separate fractions into different products in order to get what we need. We just have to make sure to use the same variable. So here, sine alpha over cosine alpha should give me the tangent alpha, and the sine beta over the cosine beta is going to give me the tangent beta. So tangent of alpha, tangent of beta. So we ended up with the other side of the equation, which is exactly what we wanted. And what do we put at the end of these? QED. Quite enough done. Good. And there we go. Okay, now number 5, you try this one. Okay, same type of problem. Okay, we've got sine of pi over 2 minus x is equal to cosine of x. But does that look familiar? The sine of pi over 2 minus x, that is a cofunction identity. When we first introduced these before Christmas, remember I showed this to you graphically. Okay, but now that we know about these additional identities, the sum and the difference ones, we can apply that to this problem. Okay, so that's how I would go ahead and work it. So let me give you a minute, okay, to see if we can make the left side look like the right side. Sine of pi over 2 minus x, we need it to equal cosine of x. Okay. All right, so that's a minute. Okay, we're going to be able to get several folks up here today. Who would like to come on up and show me this one? How, using one of our new identities, can I make sine of pi over 2 minus x into cosine of x? Okay, well, let me walk over here. I'm going to pull up my calculator. Okay, so menu, probability, random, integer. I only want one person. I'll go ahead and say 36. Why not? Okay, so 1. All right, he's the lucky one. There you go. That's okay. We'll help you out. Okay. All right. So basically, think about pi over 2, that's your alpha. X is your beta. So we just want to apply the identity, that formula, to sine of pi over 2 minus x.
So which averages like to what we did with the last one?
Mm-hmm. Yeah, we're just expanding. Okay, so remember, when you expand sine, the products alternate, but we keep the operation. So that would be sine pi over 2, good, times what?
Times
Oh, not sine.
cosine.
Cosine. Okay. And now plus or minus? Minus, okay. Cosine of pi over 2 times what? Sine of x. Perfect. And we know that's an x, yeah. Okay. Good, good, good. Now all we have to do is just evaluate these. Does anybody remember, what do we call pi over 2 if the terminal side stops on an axis? Remember, that's quadrantal. Okay. Does anybody remember what is sine of pi over 2? Somebody said it is 1. Okay. All right. So if Fawaz tells me the sine of pi over 2 is 1.
So just switch it to 1.
Yeah, so we'll just replace it with 1. Okay. So we can just put a 1 below it. Okay. Times. Oh, now cosine of pi over 2 is going to be something else. There we go. So let's look at what we have. We have 1 times cosine minus 0 times sine. But what's 0 times anything? 0. And what would 1 times cosine be? Cosine. There you go. And that's exactly what we were wanting to show on the other side. That's it. There you go. Now I'll go ahead and write it out to make sure just everybody's on the same page. So we have the 1 times the cosine of x minus the 0 times the sine of x. But that disappears. The 1 times the cosine. Good. QED. Okay. How many people got that right? Okay. If you're not raising your hand, what can I do to help? Do we have a question? Is everybody okay with why we used 1 and 0? Do I need to diagram that real fast? Okay. Then let's move on. Okay, next up. Now for these problems here, it says find the exact value of sine of 5 pi over 12. Now you'll notice it not only gives you angle measures, radians from the unit circle that you want to use, but it also tells you what you want to do with them, the operation. So 5 pi over 12, we can rewrite that as pi over 6 plus pi over 4. Okay. See, pi over 6 and pi over 4, we're already very familiar with those from the unit circle, and they do create special right triangles. So when I expand this, we should have no trouble evaluating those trig functions. Now, what is 5 pi over 12? What was that? What would that be in degrees? Okay, Skylar, what would that be? Don't know? Susie? Okay. Shayna? Oh. Alex? Okay. Who knows? Dylan? I'm sorry? Oh, 15, not 15. There you go, 75. So here's the thing. If it's given to you in radians and you're having trouble figuring out what 2 radian measures can add or subtract to give you what you're wanting, maybe you can go ahead and convert it to degrees to kind of help yourself out. How would I convert this to degrees? I'd multiply 5 pi over 12 times what? Okay, 180 over pi. There we go. The pi's will cancel. You got your degrees. Okay, and then once you know exactly what your angle is and what you would be using, convert those back and then still work with the radians. Okay, so if you're given radians, go ahead and work with those. And it makes sense because pi over 4, we know that's 45. Pi over 6 is 30. So that sum is going to give me the 75, right? So I want to use these two to evaluate sine of 5 pi over 12. So this is going to be sine of pi over 6 plus pi over 4. So the way I'm writing it, the first one represents my alpha, the second one represents the beta. Okay. And actually, if I switched it around, you're still going to be able to get the exact same answer. You just want to be careful when you're subtracting. That order does matter. Okay. Well, can somebody tell me what the expansion is? When it's sine of a sum and I have these 2 measures. Okay, so Juan, you said sine of pi over 6 times cosine pi over 4. Okay, minus? Very close. Keep the plus. Okay, cosine wants to change the operation. Okay. Now what's the next product? Cosine of pi over 6 times sine of pi over 4. Okay. All right. So the more of these you do, you're going to go ahead and start to hopefully remember them, off the top of your head. I was talking yesterday about trying to simplify these without using the triangle. Like, which one of these should we know immediately? Which 2 have the same value? Is it the pi over 6s or the pi over 4s? The pi over 4s. So cosine of pi over 4, what is that? It is 45 degrees, but what's cosine of 45 degrees? Square root of 2 over 2. Okay, sine of pi over 4 is square root of 2 over 2. If you're thinking about, the unit circle, okay, you got 45 degrees. Remember, the triangle created was square root of 2 over 2, square root of 2 over 2, so that this ordered pair was the square root of 2 over 2, square root of 2 over 2. Okay. Now let's do the pi over 6. Okay. Now we know that one of them has to be 1/2. We know that the other one has to be square root of 3 over 2. The only question is, which one is sine of pi over 6? Zach, what do you think? Don't know. Raphael? Sine of pi over 6. What's the ratio? Close. Okay, so there we go. So this would be 1/2. That means cosine of pi over 6 would be the square root of 3 over 2. Does anybody want me to draw the triangle? Okay, draw the triangle. Okay, so sine of pi over 6 is what degree measure? That's 30. Okay, so there's the 30, there's the 60. Now remember yesterday we were talking about how you could work backwards if you remember the relationship between the sides of a special right triangle. But also if you know you're on a unit circle, remember across from 30, it has to be 1/2. The shorter leg has to be half of the hypotenuse. The longer leg has to be the shorter leg times the square root of 3. Okay. So when we go ahead and say, for example, sine of pi over 6, remember we want the y over r. So the opposite 1/2 divided by the 1, that's where I got that. And then cosine would be the x over the r. Okay. So again, it's still tying back to those happy minutes that we did in the first semester. Okay, and all we got to do now is just simplify the algebra. What's 1/2 times the square root of 2 over 2? Square root of 2 over 4. Okay, then I got the plus square root of 3 over 2 times square root of 2 over 2. There you go. Square root of 6 over 4. Because they already have the same denominator, I can just go ahead and simplify that. Square root of 2 plus the square root of 6 over 4. Now, we're breaking these angles into measures that we're familiar with on the unit circle. So there's only so many extra angles we're going to be able to get when you add or subtract those that we have off the unit circle. So for a lot of these, you're going to notice a lot of similarities in the answers. Okay, especially when we go ahead and do number 7. All right. So in fact, speaking of, what we just did for number 6, I want to go ahead and do that for number 7 now. It's a cosine of 7 pi over 12, and they already broke it up for you. Pi over 4 and pi over 3 this time. So we can say that that's my alpha, that's my beta. So let's say a minute 15. To expand that, okay, go ahead and form your algebra, do all that, and get your final answer. Okay. Now I'm going to continue passing out some paper. Did anybody else need the key and has not yet got it? Okay. Okay, that's a minute 15. Okay, so here's what we're wanting to do. Let me give myself a little more room here. We have the cosine, 7 pi over 12, and we're wanting to rewrite this as cosine of pi over 4 plus pi over 3. So we're going to be using the sum identity for cosine. Do I have a volunteer? All right. And let me go to my calculator here. 34. Okay. Dylan's up. All right. Okay, good. Change the sign. Okay, so his expansion is perfect.
Cosine of pi over 4 is root 2 over 2.
Okay. Okay, cosine of pi over 3 is 1/2. Okay, and then we're multiplying those and we're subtracting. Then you can just combine them. Perfect. Perfect. Any questions? And like I said, how similar is that to the previous answer? Okay, it's pretty close because, like I said, we're not going to have a lot of extra angles that this is going to allow us to work with. Okay, anybody have any questions? Anybody not sure where he got something, where a value came from? Do we need to diagram that 30, 60, 90? Okay. All right. Well, let's see what we got here. Number 8. Okay, so suppose that sine of alpha equals 4/5 for a quadrant 2 angle alpha, and sine of beta equals 1/2 for a quadrant 1 angle beta. Find the exact value for each of the following. So we're going to go ahead and set this up, do A and B together, then I'm going to give you a little bit of time, and we're going to get some more folks up here to help me with C and D. So for these, it's telling you what quadrant you're going to find these terminal sides in. So for example, alpha is in what quadrant? It's in quadrant 2. So in quadrant 2, I'm going to go ahead and draw terminal side. So alpha represents the reference angle. Okay, it always goes back to the reference angle. I'm going to connect it to the x-axis. There's my right triangle. Now, it says that sine of alpha equals 4/5, right? What's sine's ratio? It's always y over the r, right? Okay, the opposite over the hypotenuse. So with alpha here, this would be the y, this would be the r. And you could use the Pythagorean theorem, but I'm hoping you'll recognize it as a, okay, it's a triple. So it's a, was it? 3, 4, 5, yes. There's just one thing we're missing. The negative. The 3 would have to be negative because we're in the second quadrant. That's where x is negative. Okay, so that creates the triangle for alpha. Okay, now we want to do the same thing for beta. So we're going to create a second triangle, but this one's in quadrant what? Quadrant 1. Okay, so this reference angle would be beta. Connect it to the x-axis. Now sine again is the y over the r, so the y over the r, and hopefully you'll recognize this one as a, does anybody know what the x value is? It is square root of 3. So this one actually turns out to be a special right triangle, a 30, 60, 90. Does anybody want me to run through the Pythagorean theorem to show that we're going to get that? You do? Okay. So let's say we don't know what the x is. X squared plus 1 squared is equal to 2 squared. All right, so x squared plus 1 is equal to 4. If I subtract that over, x squared is equal to 3, and if I want x from x squared, I have to take the square root. Okay. All right. Now for A, we want cosine of alpha. So the variable that you're given is going to be real important because that tells you what triangle to look in. All right. Cosine of alpha, so I'm going to look in this triangle here on the left in quadrant 2. All right, so let's see here. Xavier, I need cosine of alpha. Yes, sir. So basically the adjacent over the hypotenuse, x over r. Close, that's sine. That's the opposite over the hypotenuse. Negative 3 over 5. There we go. So cosine of alpha is a negative 3/5. Now I need cosine of beta. Ford, can you help me out with that one? So I need the x over the r value in that beta triangle. Square root of 3 over 2. Perfect. There you go. Now for C and D, you're going to need to know both cosine and alpha, cosine beta after you expand those formulas. But here's the thing. Won't we also need sine of alpha and sine of beta? But why is that not a problem? Yeah, that was what we were given at the very beginning so that we could start the problem. So we have all we need when we go ahead and expand these. So let me give you, let's say, 2 minutes. Keep walking away from it. Okay, let's say 2 minutes on this one. I'm looking for C, but if you are able to finish it up, okay, go for letter D. Right. Let's see if we can come up with our expressions. Okay, if you need to, you can coordinate with your villain buddy. Okay, those around you who have the same color card villain. Or if you're stuck, or if you need a question. Okay, okay, thank you. For once. All right, that's 2 minutes. Again, you may not be completely done. That's okay. Does anybody think they have an answer for C? Okay. Just like the previous ones, you should have ended up with a common denominator. You just pull it together into a single fraction. Okay, let me rephrase. How many people have an answer, but you're not 100% confident if it's correct? Okay, so now I see some more hands going up. Okay, would anybody just like to go ahead and share it and see if that's what we get? Okay, Christian, what'd you get?
4 minus times root 3
4 minus 3 times root 3
over 10.
over 10. Okay, what do you guys think? Okay, let's see. Who wants to come on up and show me the work to see if we actually get that? So many hands. Okay, go into the random number generator. I got 4. All right. Ford's going to come on up and help us out. Now remember, we already have everything we need. We just need to expand it using the rule and then plug in those ratios. Okay, and hopefully we're going to end up with what Christian told me. He is very close. There was just one little detail off.
Wait. Okay. I think I know what.
Okay. All right, so right now let's just go ahead and expand it. What's the rule for cosine of alpha plus beta? What does that look like? Does it start with a cosine or start with a sine? Okay, so why don't we go ahead and write it out using alpha and beta first. And then we'll worry about the ratios. So what's first? You said cosine, but alpha or beta? Okay, so let's go ahead and write cosine alpha. Okay, now we're going to multiply that by what? A cosine or a sine? Cosine, okay. In fact, cosine of what? Beta. Plus or minus? Minus. Remember, cosine wants to change the operation. And now we're going to have a product with two, what? Because we already used cosine. So it's got to be sine. Okay. Sine of alpha, sine of beta. And see here, it's just substitution. What is cosine of alpha? Negative 3/5. So in place of that, we're just going to put negative 3/5 times cosine beta. We found that to be square root of 3 over 2. Then we have, yeah, you can go ahead and erase that. Okay. Then we have the minus. Sine of alpha was a 4/5 times sine of beta. There you go. Okay, so let's multiply those together. So what is a negative 3 times the square root of 3? There you go. We can't multiply those 3's because one's a radicand and one's outside. Okay. So that is right. Over what? Over 10. Then we got the minus 4/10. And all we need to do is combine these because they have the same denominator. So negative 3 square root of 3 minus 4 all over 10. That is perfect. There we go. Now, Christian was almost dead on. What you were saying, were you right? He had told me 4 minus 3 square root of 3 over 10. Okay, what was the one thing he was missing? The minus. That was the only thing. Okay, other than that, perfect. Okay, anybody else get that one? Okay. Any of those people who were raising your hands a second ago, did you have the right answer? Okay, so a few folks. Okay. But see, once you have the formula, you're just substituting in those ratios. Okay. After that, it just goes straight to algebra. Okay. Let's try sine of alpha plus beta. Okay. So let's go ahead and expand it. Oh, and I accidentally erased that. Let's see. Cosine of alpha was a negative 3/5. This was square root of 3 over 2. Sine of alpha plus beta. Right now, I just want the rule. Rhett, can you tell me what the expansion is? Sine of alpha times cosine beta plus cosine alpha sine of beta. There we go. See, there's the rule, and now each of these four trig functions, we know what the ratio is. Zach, what's sine of alpha? Now, we can look in the triangle, or remember that was originally given to me. Oh, not 1/2. That was sine of beta. Sine of alpha was 4/5. So I'm just going to plug in 4/5 times cosine of beta. Alyssa, can you help me out with that? What do we find for cosine beta? Root 3 over 2 plus cosine alpha. Let's see, who am I going to talk to today? Kyle. Okay, negative 3/5 times sine of beta, which is just the 1/2 that was given to me. Okay. So now, what is 4/5 times square root of 3 over 2? Say again, listen. Okay. So 4, you said root 3 over. Over 10. There we go. And then we have the minus because we're going to have a negative product. 3/5 times 1/2 is a 3/10. So 4 square root of 3 minus 3 over 10. Okay. Did anybody have the opportunity to get to the end of that one? Okay. Is anybody confused by what we've been doing? Anybody having a hard time? Okay. Uh-huh. Yes. Well, we are going to be doing more proofs this second semester. We are going to have some much larger proofs. There were enough people. Now, there wasn't anybody in this class, mind you, but there were several folks in other classes who grumbled about having to do the proof a little more than they really should have. So all that kind of did was tell me I need to raise the stakes and at some point make that a grade. Things like that, whether it's a quiz or showing up on the test. Okay. Like I said, nobody in here did that, but you have a lot of friends in the other classes, and I'm sure somebody at some point probably said something about the proof, so you might know who did it, but you can just say thank you to them. Because, I'm thinking about turning something like that into a quiz or maybe including it on the test. Not this test, but definitely probably by the second exam. So, but that just means it'll be more fun, right? There you go. Yeah. Super. Okay, so we are almost done. A reduction formula. If one of the angles in the sum or difference is a quadrantal angle, then the sum or difference identity yields a single-termed expression. Since the result is a less complicated expression, the resulting identity is what we call a reduction formula. And again, we talked about this a little while ago. A quadrantal is when the terminal side stops where? On an axis. There we go, whether it's the X or the Y. Okay, so prove the reduction formulas. So basically this is like earlier where we're just going to go ahead and verify. So let's say this first one here, sine of x plus pi, I want to show that equals negative sine of x. Okay, so using x and pi, let's see. Jane, can you expand using the appropriate identity for me? If alpha is x and beta is pi, what would that be? Which would be sine x times cosine of pi plus, did you say sine or cosine of x? Okay, I'm sorry. I could have sworn you said sine. Okay, my fault. Cosine of x and then sine. There we go. Okay. So again, I'm just applying the terms x and pi to the formula. Okay. Just expanding it. Now remember, pi, if we're looking at the unit circle, okay, we're going to go ahead and rotate halfway. What's the ordered pair at that quadrantal? -1, 0. Okay, so there's no triangle to create. What is the cosine of pi? -1. Remember, that's the x value at that location. So I'm going to have sine of x times -1 plus the cosine of x times what's sine of pi? 0. Okay. So what's cosine times 0? 0. That one disappears. Sine times -1. See, there's your negative sine of x, which is just what we wanted to show. Okay. I'm going to remember to put QED. Okay. Now, we're running out of time. We still want to go ahead and do this one. We'll get that on Thursday because I'm not going to see you guys tomorrow. But I'm hoping at this point that you're really starting to see that it's just a formula. You plug in the appropriate ratio for a triangle that we've created in the past. Okay. Now, even though we haven't done a tangent one yet, it's the same idea. So consider this a homework assignment. When we come in on Thursday, one of the first things I'm going to do is use the random number generator. Somebody's going to come on up here and show me this problem. Okay, now you'll also notice the good news, did it go ahead and give you your alpha and your beta? Yes, but it didn't tell you whether it's a sum or a difference. That's one thing you have to figure out. Will these two radian measures add or subtract to give me 5 pi over 12? Okay, Stephanie. I'm not worried about that, no. No, I'm not. Okay. All right, good. Good.